Good morning, everybody. We'll give just a minute. I still see some people climbing in the door after a late night at the social event, I'm sure. I've heard the sake was good. I unfortunately missed it. All right, so this is the Secure Asset Transfer Protocol Working Group, the first inaugural meeting of it, in person at least. We've had an interim meeting once already, and we're going to have a bunch more. We'll talk about that in a minute. I am Wes Hardiker, and with me is Claire, my co-chair. You'll hear from her in a minute. The mailing list is on the bottom that you can sign up for. One note is that the mailing list is SAT, but the protocol has a P at the working group has a P at the end. Long time with we like 4-letter acronyms, and the mailing list was created with only 3 letters. So the note well is extremely important. Since this group does contain a number of newer people, I'll spend a little bit more time going over this. You should consult the lawyer for your company or something like that, but the important takeaway is that the things you say in the IETF, you're sort of contributing those, and you need to acknowledge that anything you do or say here, that includes in the chat. So if you use the chat conversation, anything that you contribute is sort of becomes part of the IETF, but consult your lawyer if you're not sure. There's actually some really good best current practice documents, BCPs, that cover how the IETF works and how the standardization process works. That includes how the working groups work. Most importantly, it also includes our anti-harassment behaviors, our code of conduct, our copyright and patent and participation related information. Again, those are well worth reading, and of course we'll stick to them. The quick summary of the code of conduct guidelines for that one is treat everybody with respect, speak slower than I am right now, limit the use of slang and phrases that not everybody may understand, dispute ideas by reasoned argument. We make sure that you have a reason for disagreeing with somebody, not just that you don't like it. Use your best engineering judgment. This is the Internet Engineering Task Force. Find the best solution for the whole internet, not just your particular problem, but we do try and create solutions that work everywhere. And we'll talk about that a little bit. And then contribute to the ongoing work of the IETF. And again, as everybody knows, for IETF116, while you are in this room, you need to be wearing a mask. So you need to be wearing a mask unless you are actively speaking at a microphone. So if you see somebody not wearing a mask, I'll ask you to please put one on. For what IETF 117, that policy is likely going to go away. But for this meeting, this is what we've agreed to. This session is being recorded, as I mentioned. It's being recorded both in audio and video. It will be published very shortly after the meeting's over on YouTube. So it's important that you understand that when you're contributing. And also note that, as I said, the chat session is also recorded. So don't think that the chat session is a place where you can say things that won't be publicly recorded. For remote participants, make sure that your audio and video are off unless you're actually chairing or talking during the session. And a headset is highly useful in order to prevent echo and things like that. For information about this working group, the purpose is really to develop a protocol to transfer digital assets between 2 different networks. Obviously, the charter has much more descriptive text about everything that we're doing, including some scope, which we'll go over in a minute. I mentioned the SAT mailing list already, and we have 3 sort of active drafts that are currently under editing, and we'll talk a lot more about those through the course of the day. Our working group meetings, our plan is to hold them at every IETF because this is where face-to-face time works the best. We also are planning on having monthly interim meetings in order. This is a fairly active group with a lot of discussion both on the mailing list and with the intent of holding face-to-face meetings. So Claire has already scheduled all of these ahead of time. I think they're on the 2nd Tuesday of every month. Is that? As close as can be to the 2nd Tuesday of every month. So please do come join us. It'll be held in Mediaco just like these, and like this meeting, it will be recorded and documented in minutes and stuff like that. So that was the sort of the chair introduction. Part of this is I need somebody willing to take notes, and there is a link in the agenda. Is anybody willing to take notes? It really just means typing some random things in. Thomas can do some of it, but he can't do all of it because he's going to be speaking a lot. Andy, are you willing to take notes? It doesn't have to be verbose. It's really just writing. Okay, it's really just, you know, taking action items, not verbatim notes. You know, everything's recorded. There's a new transcript ability that we can actually download later too, so that actually will help us in the long run. In the Etherpad, if possible, the hedgehog, yeah, if possible, and actually other people can help them. The nice thing about that application is that it's live editing, like, you know, the equivalent of Google Docs or something like that, so it's easy to do. We're going to go over the scope next, and I'll turn that over to my esteemed colleague here in a minute. We'll also talk about a terminology discussion. Alex isn't here, so I will sort of go over sort of the purpose of that that newly authored document. And then there are 3 proposed working group documents that we'll talk about as well. And at the end of the day, you know, this group started off strong with 3 documents that are, you know, actively under consideration, and we will probably talk about whether those documents are actually ready to become official working group documents, which is the next stage in the process. And we'll have time for any other business as well. And I'll come back to that in a minute after Claire is done explaining the scope, because it'll make more sense then.
Thank you, Wes. So as this is our first official working group, we wanted to spend 5 minutes recapping the scope. And this comes out of the discussion that was had at the BOF in London, and is very much fed by the IETF focus and what they'd like us to focus for our initial scope. So in summary, it's to develop a single protocol for the secure one-way transfer of any digital asset, and we will come on to what that means. Between networks, they must be agnostic to the technology of the network and the nature of the asset. We'll break that down in the next slide, but just to give you an overview of what the architecture looked like, this is based on, roughly based on a 3-phase commit between gateways. So it is just the transfer of the assets between the gateways that we are focusing on for the first initial scope. Thank you, Wes. What that does mean is that with the single directional, unidirectional, to use the official term, asset transfer and gateway to gateway, what that does mean is that out of scope, that we would very much like to roadmap for future discussions, is the multi-directional or asset swapping. Anything that's not included in our description or in our terminology and our definition of what a digital asset is. So we might have to limit the assets that are covered. And that does mean as well, because we are making sure that we're agnostic to the technologies, that we are not going to be covering anything that is network protocols for locking before SATP, as that would then expand the scope quite dramatically. So with that in mind, our working group meetings and our interim discussions will be focused on the scope itself. We may be able to discuss other elements during any other business. Happy to continue to use the mailing list discussion for other scopes. And of course, there is the idea that once this protocol is far enough down the line, and we'll come on to what that process looks like, we can then start to bring in other points of discussion and expand the scope for future documents. So what does that process look like? This is a high-level flow. As fairly new to the IETF, Wes has kindly taken me through the process. It's not as linear as it looks. You can see there's a feedback loop. So where we are today is step 1. We've got 3 documents. We've started them. We do need to agree that we're all happy that this is the correct starting position, that there's no major disagreements with what we've got so far and the position that we're starting in. These will then be called for formal adoption as IETF working documents. Simply means that they're officially the documents that we are working on, and these are the documents that will then be taken through the rest of the process. We will continue to have the working group discussions, the interim meeting, discussion on the mailing list, and I know the authors and editors are having side meetings and side conversations as well. So that will all continue. The feedback and the outputs of that that is within the scope will be edited and revised in the document, and we can come on to where that's stored and how to do that. Once we're ready to take our documents further, we'll be then opening it up for peer review outside of our working group and into the wider IETF. This is where the feedback loop comes in. And then eventually to implementation. And implementation is sort of the end goal of what we're trying to do here. And it's past that point that we can then start to look at other discussions and other areas. Thank you. So that was quite a quick 5 minutes. If everyone's happy with that, we can continue on to the terminology.
John?
It's on. Sorry. When you say transfer, is there an assumption that it's gone from the old place and it's only in the new place, or it might be in both places, or is this a higher level question?
Yes, no, that is exactly what we mean by transfer. We'll come on to that. I think Thomas has got some slides that will cover that in more detail.
Okay.
But yes, that is the core understanding.
Okay.
So it's to avoid double spend is one of the areas.
All right, thank you. Actually, I'll add one more. Beyond implemented is deployed. So there's really another step, and that's really our goal, right? Didn't think about that until just now. But so one of the things that I think when Claire and I were talking and watching the discussion happen on the mailing list, we love the fact that the conversation is very vibrant on the mailing list. But there is some different people throwing around different terms, and we sort of decided it would probably be good to agree upon some terms. So we wanted to ensure that, you know, all the documents were using a common terminology set. They were all sort of based on the same vocabulary. When we have discussions, we should try and use the same terminology too. It's very easy to slip into different things as each person has a different goal for how they might want to deploy the protocol in the end. But we need to make sure everything sort of matches the scope. Alex, we asked Alex to take this on, and he was very willing to do it, and already has drafted a bunch of terms. He's not able to be here today, so I'm sort of giving this in proxy for him. This is the list of existing terms that he has come up with. There is a document in a GitHub repository, and this will get turned into sort of draft format text and either included in one of the existing documents or published as a third one. It's technically not in our charter, but that's really not a big problem to add. Add a vocabulary document really shouldn't bug the IESG, I don't think. I'm not going to go over all of these today, but I was going to throw out sort of some of the important ones, and the wording, you know, I think this is Alex's first pass, but there's a few, you know, important things that we might want to talk about. For example, a digital asset is any asset that is purely digital or a digital representation of a physical asset, right? That is what we are talking about transferring. Now, after each one of these, I'll pause for a little bit, and if you have a comment about, you know, making sure that we want to include or exclude, I guess, something, or, you know, you disagree with the phrasing, the phrasing will be, I'm sure, iterated much more over the mailing list, but these are sort of the important ones I wanted to hit today. So do feel free. I didn't mention in the beginning, everybody, please do scan the QR code and log in through MeetEcho officially, and that's incredibly important because the number of people that log in for the meeting actually dictate the size of the room that we'll get. And you don't want to be in a small room, let's just put it that way. Regardless of COVID, I've been in some pretty warm small rooms that were way overcrowded. So everybody please do use the QR code, or you can go to the agenda on the website and click the video button, and that'll log you in as well. The next one on the list is, and again, interrupt me at any time if you have questions or comments, is digital asset owner, which is the person or organization who is the legal owner of a digital asset. The P shouldn't be in the who. I actually don't know if whether I copied that or it's actually in the published version of it, but we'll do micro editing at a later point. And there's been some interesting aspects of ownership and value and things like that that have been discussed on the list. Does it actually have to have value to be an asset? But we won't dive into that today. And then, as John, go ahead.
Keep bothering you.
Yeah, please.
What does legal mean?
So that is one of the words that I looked at that sentence to,
Yeah.
and because legal has so many different jurisdictions. So that is a good question. And so
I'm assuming you mean it's the owner sort of within the context of whatever the thing at the end of the protocol is.
yeah, and I would also think of it as the owner within the existing asset network,
Okay.
right? Legal probably should be dropped from that sentence, but I'm trying to think of, we want some sort of notion of there is an owner and
Well, yeah, and I guess this, without trying to rat hole too much, I mean, in the real world, the legal owner and the owner on the piece of paper are usually, but not always, the same. And yeah.
Thank you, John. That's a very good point, and we should definitely edit that and refine that. My understanding, and this is speaking not as a chair, is that this should be representing the owner of the asset in the originating network in terms of the person who is authorized to move that asset around. So we can definitely clarify that, and it's a really good point to take away. Thank you.
I'll say between the two of us, I'm more the expert on the IETF protocol and she knows everything else. So next up is gateway, which is the collection of services which connects to a minimum of one network or system and which implements the secure asset transfer protocol. So the gateways participate between themselves using the developed protocol to transfer an asset from one originating network to another one. That is the scope of the working group today. We will say that in the future, there has been discussion of, well, can't we also define protocols, what's used inside of a network, or maybe this protocol can be used, but that's not within the initial chartered scope. That would be a future work item if it looks like there was a common way that people wanted to do interoperability inside different networks. And then back in part to John's point earlier, there's both burning and minting, and that is a transaction carries out this digital asset and transfers it from one network to another, and it does that by destroying or burning the value of the digital asset in the originating network and then recreating it or minting it in the new network. So that is what the transfer essentially amounts to, is a simultaneous destruction and creation. And obviously that is a potentially hard thing to pull off, to get that right, which is why we have a whole working group around the problem. So that is just the end of the terminology. As I said, there's actually a bunch more terminology if we look at the full list, but those are, I think, the important ones that I wanted to cover today. I'll note that there's a bunch of other ones. If you think of something missing, then it should probably be added to the list, and we can bring that up on the mailing list. One, I think the most important thing to note in my mind is the scope of this working group is not just standard blockchain to blockchain, right? We actually have a generic scope for transferring a digital asset from one location to another, regardless of the technology that is storing it on either end. And that could be a distributed ledger, it could be an Oracle database. Different institutions may have different ways of storing value on their side. So we're trying not to, one of the reasons for this terminology list is we're trying not to use terminology that is specific to one type of asset network or one type of implementation on one side. And of course, generic terminology is hard to get right in a way that everybody agrees to. But as you're talking on the mailing list, please do try and we'll slowly converge to a standard set of terminology. So. With that, any discussion on the terminology? Good news is we're ahead of schedule, but that's okay because the other stuff will take a while longer. Then we will go on to the architecture document next. I should pause. Can somebody on the remote speak up and make sure that you're hearing us? I did not check that earlier, and I'm assuming that we are audible, but.
I can hear you, Wes.
Excellent. Thank you very much. I should have done that earlier, but nobody yelled yet. So, all right. So Thomas, we'll turn that over to you next and give us 1 second to pull up your slides. You're doing core first, right? Architecture first. Okay.
Can eat the mic. Okay. And for people online, I presume you guys can hear me. So yeah, next slide, please. So I'll be doing this set of slides and then the core, which is the core protocol slides. But the format is that I'm just going to do like quick 2-minute, 5-minute update of for people who have been, following this for the last couple of years, and then the rest of the slides are kind of background for people who are new perhaps to this working group, who may want to see the motivations behind this, some of the design principles behind this. So, okay, next slide, please. Sure. No. Do I need to drive it? No. Okay. Okay. So this is the quick updates to the people who've been following this draft. So together with the draft, we have this PNG one-page diagram that's actually what we call the annotated colored flow, because it's got complete messages with yellow highlights and comments in blue. And I invite you just to follow that link. There's a bit.ly link that has the diagram. We are now version 16 of it. We found that trying to do stuff in detail on the IETF plain text was very difficult. It was important everybody was on the same page, literally. And so we've been developing this. This is version 16 of it. The version 16 thing has there's no relationship with the draft count. It's just our way of updating the diagram. So for the draft itself, version 03, which was uploaded literally the week before the IETF, before the cutoff date. So we added some text specifically saying the gateway is trusted, because this was one of the discussion topics that came up in the interim meeting and other previous meetings is, do we trust the gateway? Explicitly trust, and that's an assumption, right? So that sort of sweeps away a whole bunch of set of problems about, well, how many gateways do you need to have? What's the definition of trust, and so on and so on. The second big thing is, so we've been having this discussion about context. So when we first started this working group, there was this question about who actually what triggers, or who triggers the flow. And so if you look at the diagram, there is in fact an application. There's app 1 and app 2, meaning originating app and destination app. And we assume there is some context there that's out of scope, or how the application talk to each other and so on. That's a business application, business logic. It's out of scope for us. What we do assume is that somehow these two endpoints are going to share what we call a session ID, and the session ID is a number, a string, or whatever that is included in the flows, so that the gateways know that this particular handshake is for this session ID. And the reasoning behind that is because you could have two applications, business applications, conducting multiple transfers, and some of them, or even all of them, could be going through the same peers gateway. And so the gateway themselves need to know what the session ID is. How we derive the session ID, it's either out of scope or TBD. We're just saying it's a string, a unique, globally unique string. And lastly, I think part of the process is we would like to ask the working group to take this, adopt this version 3, draft 3, as a working group item, the starting point for the formal work of the working group. Next slide. Thanks. So okay, so if you see the red thingy marker flag, it means okay. Changing topic. So problem statement, why did we start this whole thing, 2 years ago? So for those who are following this whole, pre-FTX blockchain thing, blockchain world, and all sorts of stuff, there are too many networks out there. In fact, I've been saying for a while now that this is very reminiscent of the days of the LAN technology. For those who are old enough who know what IBM SNA and DECnet, and for those who are big fans of Ethernet, you guys noticed that Bob got the Turing Award last week or the week before, the guy who co-invented the Ethernet. So what we're seeing now in this digital asset network space is the same problem. So poor scalability. So you'll see these, news items, bridges being hacked and so on, and there's a lot of reasons for that. And I think it's because they're using proprietary bridges that really have no formal protocol specifications and have not been analyzed both at the protocol level and the implementation compliance level, right? There is no spec, which is you can't do any compliance against a spec if the spec doesn't exist. And of course, there's lack of standards for security. And if you just Google, good one is, if a problem makes it to the front page of CNBC, then it's a problem. Just Google CNBC. I think it's July last year, $1.4 billion lost through all this crazy, they call it bridge, hacking the bridges. Next slide, please. Next. And so this is the diagram you saw before, and we'd like to re-emphasize again, we're only dealing with the yellow box, okay? And so we don't know what the technology is for the origin network and the destination network. And so how a gateway, say G1, deals with the interior constructs of network 1, that's G1's problem. Same with G2 and network 2. And so as the chairs were saying earlier, we could be talking about a monolithic system. So, for those who are young enough, you may be surprised that mainframes are still being sold, and there is a shortage of COBOL developers, for those who know what COBOL is. And for those in the financial industry, you'll nod, because yes, you are desperately looking for COBOL developers. By that I mean there are these monolithic systems out there that that handle transactions at high volume, and so we have to also be cognizant and address that segment of the market, because a lot of these financial institutions have poured billions and billions of dollars into their IT infrastructure, and they're not going to rip that out just because there's some new technology down the road. It's really sort of our job as engineers to make sure there's some integration path that makes sense, that's technically sound, and implementable. Next slide, please. Thank you. So the goal, this is like kind of formalish language. We had to define the goals when we were doing the BOF, So it's a protocol to allow the movement of a value-bearing data object, right? So if you guys are familiar with DLT networks, blockchains, people use the word token generically. So it's on-chain, meaning it's on the ledger, it's on the blocks or the records of the ledger. And yes, it's just a byte string, but it signifies some economic value that the human beings or the community around it have agreed upon to assign value to that data object. So we're trying to move value across, and in both networks, we assume there's some construct that captures or represents that value uniquely. However, as this gentleman here is saying, yes, we have to avoid the double spend problem, right? This is key, and you'll see why we go through all sorts of two-phase commit, three-phase commit, because this is quite a difficult problem. And lastly, we need to have some kind of a protocol that allows, in case of dispute between G1 and G2, or the owner of G1 and the owner of G2, there is enough evidence so that you could hire a sort of independent authorized third party to go through the post-event the logs to say, yeah, there's one of these guys misbehaving, or one of these G1 or G2 or both are dishonest. So that's kind of the third requirement. Next, please.
One quick point. So asset you have there in quotes, and as I mentioned before, we were talking about digital assets, and that's been a discussion on the mailing list of, I think the conclusion on the mailing list is anytime we use the word asset, we really mean digital asset, right?
Yes.
Okay.
My bad. I keep saying asset, and Alex keeps adding the word, digital in front of it. So thank you, Alex.
It just brings us back to the terminology question and why we're doing it. Yes.
Yeah. So next slide. So desirable properties. So it has to support private networks, right? And this is a big contention. When when I have dialogues with undergrads at MIT, I have to explain to them, there is no such thing as a public open internet. All these networks are ISP networks. So, they're a sequence. I have to use the word sequence. So, when you're watching a movie off, Amazon servers that are out at the, West Coast, and you're sitting in the East Coast, this thing, these packets are traversing private networks, right? And so we use, I think this is also a terminology thing, we use the word private and public to mean permissionless, meaning that you need to be authenticated, authorized to conduct transactions on either, and that's a terminology question. So it has to be, the worst case scenario is both of them are private networks, and that's quite possible. So if you Google News, if you look at news like Goldman Sachs doing exploratory work, the Singapore government has put a lot of money into this. You'll hear TradeLens and so on. That's a JV between IBM and Maersk, the shipping company. If you dig deeper, you'll see these are private networks. They might be as a helper utilizing a public permissionless blockchain, but if you look deeper, it's all private. So we have to be ready for that scenario. It has to work, as I said before, if one side or both are legacy systems. And then it has to have the ACID properties. I've got a slide on the ACID properties, which is a borrowed terminology from databases. For those who remember doing the undergraduate database courses from the 80s and 90s, you'll remember, he's nodding, you'll remember these, these words. Next slide, please. So I apologize for long-timer IETFers because this is going back to 101, but I kind of feel I have to explain this because these are the two principles that we have included in the architecture document. So the first thing is the opaque resources principle, and that is literally a borrowing, and we're stealing from the autonomous systems principle. And so the idea there is that you can't design a protocol that is dependent on a data construct in a remote network. Why? Because you have no control. Many reasons. That remote network might change the API. It might change. It might go away. You can't. It's just becomes unscalable, right? And so the assumption is that in our design, whatever the ledger is, whatever the database is on a remote network, you can't see it. Don't design with the assumption that you can see it, because in fact you can't see it. And the other thing is maybe lack of a better phrase, the externalization of the value principle. So the gateways themselves need to be agnostic, oblivious to the value. The role of the gateway is to do the fastest way to do the transfer commitment, to finish the commitment, and to ensure both networks are consistent. And you hear the word consistent used, meaning that there's no double spend. Literally what that means. And this is the analog to the end-to-end principles. Principle for those who are on the DIN mailing list with Lixia there's a thread. This is coming back there as well. This whole end-to-end design principle. Next slide, please. Thank you. So AS, okay, for those long-time IETF, you can follow, you can go to sleep. This slide or the next slide. Independence of each network is really what the AS means, right? So if you look at an ISP, typical ISP network, it's an independent network. It doesn't rely on anything outside of it. It's got clear boundaries, so for typical ISP network, it could be one routing domain, it could be multiple subdomains and so on. But when it talks to an adjacent ISP network, it uses specific types of routers, border routers, and running BGP, for example, right? So the BGP portion is standardized, and that's what we're trying to develop here, is the gateway protocol that's akin to a BGP. Okay, next slide. And end-to-end principle, the function, the context is at the endpoints, right? And this, by the way, this is it's that document down there, the Salzer, Reed and Dave Clark's document 981. It used to be called the end-to-end argument because they did have a long argument in public about should we put encryption as part of the internet design, and the conclusion is no. The role of the TCP/IP Internet is to do routing as fast as possible, do best effort delivery, and so on and so on. Encryption really needs to be at the endpoints, which is why we end up having IKE and IPsec and so on working beautifully because of this principle. Okay, so I will go. This is just an overview. Rama is going to do his slides, and then I'll go back to this. So we divide the flow into 3 stages. Transfer initiation is currently a bit of a hand wave there because this is most of it is out of scope for us. The stage 2 is where Gateway 1 makes an assertion that it's done its job in locking or disabling the asset in the origin network. And then the other side, Gateway 2, has to formally give a response to this, and we just call that a receipt. And then stage 3 is when both sides are ready to pull the trigger, literally, and then the Gateway 1 will issue a final commit message. And if you guys know two-phase commit in databases, you'll see this is actually a 3-phase commit, which is a variant of the two-phase commit. And again, take a look. Please have a look at that annotated diagram again. We'll come back to it later on. Next slide, I think. So asset properties, for those, this is a refresher for your undergraduate database 1 course. Atomicity, so the transfer must either commit entirely or fail entirely. It means failure means there's no change to the asset ownership, right? That's atomicity. Consistency, we want no double spending, meaning that the asset has to be located at one network at any one time. Isolation, when this is happening, the owner, remember there's this question about the owner or the application, should not be able to interrupt to produce a double spend. Now, this doesn't mean that an application cannot abort or terminate. Yes, there's, in fact, in that annotated diagram, I think it's line 3.4, before 3.4, applications can cancel, I don't know, abort, change my mind, I don't want to transfer, that's possible. Once you get to that trigger point and the trigger's happening, no, it's too late. Durability, so we spent a lot of time in the group talking about gateway crashes, and I think there is a document somewhere that Raphael wrote that talks about what happens, what are the options to increase reliability. So in this case, durability means that once G1 and G2 commits and one or both of them crashes, immediately after that commitment, it's done, right? So and the assumption again is that the G1 and G2 have local logs to allow them to recover, and the logs are persistent, meaning that if the machine dies, fine, it's on disk. Next slide. Okay, I think I'm done. Any questions about this? I think the next set of slides goes into more detail, and I'm trying to save time, on this slide because that set of slides is kind of a bit long.
Thank you. Any questions for Thomas about the architecture? And I think, Thomas, you had said you were hoping that the document was ready to be accepted by the working group and could be adopted. Is that the case?
Yes, correct. Yep.
Okay, why don't we go ahead and take a quick, anybody want to make comments about whether it's ready to be adopted or needs more work before the working group adopts it? Typically the reasons for not adopting would be that we disagree that it's the right approach, right? So, or that there's conflicting proposals, and that doesn't usually happen for the architecture document, but it's possible. Then seeing none, let's start with a poll, because we should all learn how to use Meet Echo. Is the architecture document ready for adoption? And I will start the poll, and then you should be able to use the QR code to indicate your answer. You will want to raise your hand if you think it's ready, and you'll want to not raise your hand if you think it needs more work. This also tests how many people are awake in the room. So far, there's 11 people awake in the room. So you can also abstain by not doing anything. All right, we'll call that good at 12. We'll, of course, reconfirm everything on the mailing list. The IETF does all of its work on the mailing list. This is face-to-face time to promote interaction. But all right, thank you, Thomas. And we'll turn to Rama next with your slides. And you can request to share them if you want to drive them yourself, or I can do that for you. It's up to you.
You can do that, plus just use the latest version of the slides.
So they should be up. Let me make sure that this is the right slide deck. Unfortunately, I don't think it is. I think this is the other one before you redid it. So let me do it another way. Give me a second. I knew that was going to happen. Yes. All right, so go ahead and we'll start with that. Does that look good?
I think that's the latter part of the deck. You have slide 8 on.
Oh, yes, I'm sorry. You want slide 1, don't you?
Yeah. All right, can you zoom into it a little bit? So I guess full screen.
It's full screen here, so.
Oh, okay, that's fine. Sure, we can just move to the next slide. Yeah, thanks. So the goal of this document is to document several compelling use cases for the secure asset transfer protocol. And first, on this slide, just describing a snapshot of the world as it is today in the blockchain ecosystem. So what you had is you had several different kind of blockchain and distributed ledger technologies. You must distinguish the two, because blockchains are a special type of distributed ledger. Yet several of these technologies proliferate in the past decade, after primarily after Ethereum came into the picture, and people started building their own private networks to run a restricted portion of some kind of real world workflow on those networks. So what you ended up with was what the industry calls minimum viable ecosystems, where you have a network that is only devoted to, say, running a trade logistics workflow. Trade logistics means the documentation around managing the shipping of a consignment of goods that's destined from one country to another, for example, via an international shipping carrier. So it manages that. A trade finance network is geared towards just managing the financial aspects of the export-import process, whereby an importer makes a commitment to pay for goods that the exporter sends to it via guarantees issued by bank. And you have various other kinds of networks. I'll come to some specific examples later. What the problem that results from having all of these different kind of networks, and also networks that run on different tech stacks, is that you have a partition of the of what should not be a completely partitioned world, and there are partitions of different kinds. You can have digital assets that are that lie, or that are recorded on one particular ledger within one particular network, that are not accessible to a different network. But in the real world, these assets need to move around for various purposes in order to fulfill the different workflows. What happens if they cannot do that, or then you need some kind of an ad hoc or a mechanism, or some sort of a trusted third party to enable that kind of communication of the assets as well as the state to happen across these different networks. And this also another result of the partition is that you have workflows that are limited to that particular network, even though in the real world these workflows are actually part of a larger workflow. And so the any two networks or more, really what you want to enable is their workflows to be able to link with each other when the need arises, and to be able to trade assets. And finally, another kind of partition is because you have these different kind of networks, their user base can be quite distinct. So a particular user can be served by a given network, but then we also want to enable user mobility. Users should not be stuck to one particular network, one particular vendor. They need mobility. So that these different kind of partitions, and the notion of blockchain interoperability, of which secure or DLT interoperability, of which the secure asset transfer protocol is one aspect, needs to address all of these. Next slide, please. So one major example, and this has been gaining a lot of interest in the past 2 years especially, is central bank digital currency. And here you may have seen a lot of news reports on different countries, as well as different groups of countries trying to figure out whether they can adopt central bank digital currencies. And a lot of experiments have been going on in this respect. One example I can mention is the set of experiments that have been going on in the EU for in order to figure out the feasibility of a digital euro. And there's something that we at IBM were involved in. We built an experimental POC for the Bank of France and HSBC about a year and a half ago. But the landscape of the central bank digital currency involves sort of a two-layer model, where you have wholesale CBDC network, and then which is really a network connecting the Reserve Bank or a federal bank in a particular country, or a particular maybe perhaps a group of countries, and and the and their connections with various commercial banks. So that's one layer. There's another layer of CBDC which involves completely your normal retail operations, and there it involves commercial banks as well as clients. It could be usually corporate, but could also be people like you and me. So the different networks managing different scopes is inevitable, and this particular kind of a classification of wholesale and retail CBDC is well known in this particular world. Exactly where it will converge to, we don't know yet. Next slide, please. So in the this is a scenario that shows how the different networks or why the different networks will need something like SATP. So you have the whole example of wholesale CBDC network at the top, and different retail CBDC networks at the bottom. The wholesale CBDC network is where you actually have minting of real currency, and where the federal bank or the Reserve Bank injects money into the system. So there will be scenarios where liquidity needs to be injected from the wholesale CBDC network to a retail CBDC network, and also across different retail CBDC networks for cross bank payment purposes. You will need currency to be transferred. This involves, if you can model these the currencies as tokens, they effectively become digital assets. They're fungible digital assets. So there is an added catch over there. But you will need there will be scenarios where those assets, or some defined quantity of those assets, need to move one ledger and then be and be recorded on a different ledger. It may belong to the same party, that is same part, the entities representing the same party in the real world, or it may be transferred from one party in one network to another party in a different network. So, but this kind of scenario is going to be, I mean, it is already necessary, and this is sort of part of the experimentation that's going on. Next slide, please. Another use case involves the transfer of digital artwork and associated regulatory compliance that has to be done with it. So a lot of artist communities at present seek to sell artwork that is created in digital only manner. So these assets are created and maintained on these software systems, typically network underlying that is underneath which lies a distributed shared ledger. And these artwork can be represented using standard file formats like JPEG or and so on. The just the presence of artwork doesn't make any sense. You need the ability to for the artworks to be commercially moved, transacted from one party to another party, and the if somebody sells an artwork, they expect payment. That's another thing. When these artworks are being sold across national boundaries, the particular tax laws need to be followed. So whenever a particular artwork is being transferred from party A to party B, often from one particular network, one particular ledger to another, automatically taxes must be directed at the point of sale to ensure that the rules of the government rules are actually followed. So at this point, there two things can happen, or two things will happen. Artwork will be moved. So artwork is in the form of a digital asset represented using some kind of token. The generic term NFT, a non-fungible token, and there's also the tax, the amount that must be directed in taxes. That is also a digital asset which can be transferred within a particular network, depending on how those networks are structured and what scopes they're restricted to, or those taxes can be actually be tokens moved from one network to another. Either case, if we have a cross network movement of an asset, be it artwork or be it currency, we will need the SATP. Next slide, please. So this is actually a scenario which has various different aspects, not just SATP, but I'll just talk about the SATP aspects of it here. There are, I mentioned those minimum viable ecosystem networks that have been created, that have been coming up in the past few years. One network which Thomas mentioned was TradeLens. So the network you see at the top right, that approximately it's inspired by TradeLens like network, which manages trade logistics. So we don't have to go into the internal workflow of these networks. Just think of a network that is managing trade logistics, where you have a seller and a shipping carrier that are maintaining a contract whereby the seller hands over a consignment of goods to the shipper, and the shipper then produces the proof of shipping in the form of what is called a bill of lading in the trade industry. Network to the left is trade finance, which when you boil down to it, it registers and enforces a trade and payment contract, which is called letter of credit in the financial world. And what that does is it enforces an obligation on a buyer or the buyer's bank to make a payment upon production of proof that goods have been dispatched. So you can see here there's a link between the two networks. The letter of credit on the left side network needs to trigger the shipping in the right side network, and the proof for shipment is produced in the right side network, but it needs to be consumed in the left side network. In the real world, people chose to, or the enterprises that are building these networks chose to separate these processes for particular for good reasons. But once these networks are built, you do need interoperability, and let's see why. If you go to the next slide.
So one quick comment before we shift
Yeah.
slides. So some of the elements of this flow is actually future scope of the working group, right? So the bill of lading and stuff like that. Just for purposes, we're documenting use cases that may require sort of version 2 of what the working group produces, correct?
Correct. Yeah, the next slide just talks about the application of SATP. If you go to the slides, 2 slides later, then I'll talk about the future scope, just briefly before I go to discussion. So thanks. So the letters of credit and the bills of lading, they represent workflow stage, but they're also digital assets in their own right. In fact, the bill of lading is considered a real, a tangible financial asset in the financial world. It can serve as a title to the shipment of the goods, and can also be traded as a security or used as collateral. So you can imagine the two networks. You have a trade logistics network, which originally creates and gives possession of the bill of lading to the seller, but then that seller needs to transfer. In order to claim payment, the seller needs to actually give the bill of lading to the buyer's bank, which is on the left side network. So that is a direct use case for SATP. So you have the bill of lading that goes from the trade logistics network to the trade finance network via their SATP gateway. So the yellow part just highlights which part we are focusing on. We don't care what's happening inside the networks. We just care that the gateways affect the transfer using the standard protocol. Similarly, the letter of credit may need to move in a particular scenario where if your buyer or your importer happens to want to leave one network and move to a different network while an export import is going on, then he might want to move. He would want to move his operations to a different network. So there, the letter of credit can be modeled as a digital asset, which can be moved lock, stock, and barrel from one trade finance network to another. Yeah, next slide. Just touch upon the future workflow or other future possibilities which involve an extension of SATP, so which will involve recharting. So just mention that quickly before going to discussion. So what you see here is sort of fusion of the trade finance network with the trade logistics network. So this actually, the flow here represents what's going on in the real world, where these two workflows are interlinked. So you have the trade logistics network, which actually depends on what's going on in the trade finance network. That is, it needs to know what contract was agreed upon, represented by the letter of credit. And finally, the bill of lading needs to be communicated. That we already talked about. The original use case that inspired this actually involved the sharing of information and not necessarily the movement of assets. So what you have is you have a particular each of these networks is running some state machine, and what you want is to be able to communicate information about the state in one network to a different network, and that is strictly speaking a slightly different way of different thing you're doing from SATP, which is moving an asset from one network to the other. But that's also something that requires gateways and their ability to communicate some piece of information, which they don't care what's in that piece of information, but a generic protocol that communicates information. We just call it data sharing. It's referred to in the architecture document as well. Thanks. I'll stop there. So yeah, these are just discussion points. Would like the community to give feedback on whether the use cases are compelling. Do you believe that the covered set of scenarios are comprehensive? Or are we missing anything major? By the way, we are all. If you have any other use cases, something that is in a different industry, which feels like SATP is just the right tool to apply to it, please let us know, and we can add it to the use case document. And finally, is the SATP protocol appropriate and adequate for these scenarios? Thanks.
Thank you, Rama. Does anyone have any questions or comments on Rama's document before we move on to these questions on screen? John, thank you.
I mean, I have to ask, how does this relate to ISO 20022? Because it already does a lot of this stuff, and it's widely deployed. But, it's not ours. Which...
Okay, I'm not familiar with the standard, sorry. So maybe I can look at
ISO 20022, it's an XML-based standard. It's what SWIFT uses for interbank transfers. It's what the American RTP and Fed now are going to use for instant transfers. I believe it's what most European banks use for instant transfers. It's got stuff for pay later. It's got stuff for securities. It's like, honestly, I'm shocked you would get this far without doing a pretty deep dive into 20022, because like in the outside world, people will say, we've already solved this problem, other than the blockchains, which nobody cares about. And I'm not saying not to do this. I'm just saying this seems to be a big hole in the investigation. ISO 20022. If you go to ISO 20022.org, you can learn lots about it.
Thomas Harjana, a quick answer to that one. We actually had two SWIFT folks at the BOF in Philadelphia. When was that? July. So, and at least on the MIT side, we've been engaging the innovations group there. So they're well aware of this. I don't know if the ISO XML thing handles tokens, NFTs.
No.
That was one of the things that they got me interested.
Yeah, I mean, it probably doesn't. The thing is, I mean, if you look, basically, it's a meta syntax, you know, and this does stock transfers, and this does instant payments, and this does pay later, and this, you know. So I think they would say if people cared about NFTs, we would define a syntax for NFTs, and they'd be done. So again, I'm not saying not to do it. I'm just saying,
No,
I would want to see a more. I would want to see a clear story about why this isn't just duplicating stuff that, and people aren't going to use it.
yeah.
Thank you. I think that's a valid. Sorry, Rama, please do.
Okay. So, no, just to directly respond to that question, there are some use cases I cannot talk about because they're confidential, at least from IBM's perspective. But as Thomas said, at least the standards for Swift interbank messaging do not involve the SATP style atomic transfers of tokenized assets. That's a very specific thing we're trying to solve here. And I think these companies are actually looking for something new, because if they move to using to connecting systems built on distributed ledgers or blockchains, and they actually want to transfer a digital asset which has to be burned in one side and minted in another side, that existing standard does not cover it. So the specific standard I can go and look up, but I think this part is not covered.
Thank you, Rama. May I make a suggestion then that potentially what we might want to include somewhere is a comparison about why SATP is needed with the ISO 2022 in mind?
Sure.
And we can draw that down in a bit more. So we'll probably do a call for authors on that one to start that conversation, have that as one of the discussions. So thank you very much.
Is the place for that the use case document or somewhere else? Claire?
That is an excellent question, and that's probably subject to the room. So the 3 documents we have now, right, are the core protocol. That's not the right place. The architecture document or the use case document. To me, it sounds more architecture than use. It's like, why is this different, or how is this different? But
Again, I'm shocked you guys don't know about this, but yeah, I'll send you a note with a couple of links.
all right, Rama, I think that's good. I think we will do a quick call to see if everybody's awake again. It is Friday. I recognize that problem. So. So I started a poll. Actually, Rama, can you turn off your screen so we get the QR code back? It's not there when you have your video on, in case people need to re-sign
Okay, I
in.
can. I have the poll window on, and I can't click the
turn
video.
Turn off your video in Meet Echo. Hit the video button.
Yeah, it's not accessible as long as the pop-up is up.
Actually, turn this off. Oh, except it's closed. All right, never mind.
Sorry.
We can kick you out, but we're stuck too. Oh, there you go. You did it.
No, I didn't.
Oh, no. Claire did it. And again, this is non-binding, and everything will go back to the mailing lists, but that it's useful for the chairs to see if there's any discrepancy that are hiding in the room. All right, I'm going to introduce the next one. All right, I think that's good. Very much in favor of it being ready for adoption at this point. And we'll do a last call. We'll do a call for adoption on the mailing list shortly.
Okay, thank you. Okay, thank you for that. So moving on then, back to Thomas for the protocol documents. So this, I understand, is the deep dive of the flows themselves. Thomas, over to you. Thank you.
Thank you. Next slide, please. And remember that the yellow bit.ly thing? Yeah, worth pulling that up, because I'm going to be showing some of the diagram, but not complete. And it's better for you guys to have a look at the complete version. So as for quick updates, so the flow in the core spec now matches again the version 16 of the nice annotated diagram now with the session ID. We now have, so we went through so many terminology discussions about, like, is it a lock assertion? You know, what is it? Is it, in fact, I think we started off with lock evidence, which is the word I think we started 2 years ago with. And one of the things that became very clear is that a gateway, G1 and G2 gateway operator, the best they can do is to provide a signed assertion that they've done the right thing. And this is very important for private networks because gateways may not be able to export evidence proof for that specific type of network. There are networks that you could do that, but not all networks can do that. The other thing is that now the claims carries the asset ID and asset profile ID. We'll see in the next couple of slides. And of course, as before, we would like to request this document to be adopted as the starting point document for the working group. Next slide, please. So this is what the message looks like. If you look at the draft section 8.3, basically we're saying message type is now lock assert, and there's a claims section there which has a claims body, and that's where the statement. So this is a signed statement, right? And the owner of the gateway, the operator, is let's put it this way, is liable, financially liable if it lies. Next slide, please. And the assertion itself, the claims looks like this. So it has to have a gateway ID, network ID, and set of assets, an asset ID, and asset profile ID. Now, we have gone through so many discussions about so an asset profile is the definition of the composition of the asset, which is completely out of scope for us. Like this is where regulators come in and say, look, you know, this is the type of asset, this is not a type of digital asset. The best example I usually use is when you get in your mail a prospectus, you know, I'll use an example that's close to home in Boston. You know, Fidelity down in Summer Street is going to produce a new mutual fund. You get this letter in the mail with a piece of paper. Actually, it's a booklet defining what it is, and it's going to be, you know, whatever 30% in blue stock chips, whatever it is. But you're reading it, and that document is not the asset. It's a profile. It's a description. It's a prospectus, right? And we think each of those prospectus documents needs a unique ID because you want to know where it came from, right? And the reason is because it's quite possible that gateways will be operating in different legal jurisdictions. And so it might be a case where a gateway operator says, no, sorry, I can't handle this, you know, incoming request because our legal jurisdiction does not recognize that specific asset profile. And so the profile ID needs to be included there. And the asset ID, again, this is an example out of a Tezos network. It is the identifier for lack of a better word, the token, the asset. Asset data is optional right now. I think it's blank. And what this assertion claims body is saying is that the asset state is in a burned state. It has been destroyed, disabled, burned, whatever the technology is used in the origin network. And there's the timestamp when this thing is supposed to happen. Right now, depending if you're talking about DLTs and so on, this timestamp could be this timestamp that the gateway you know, signed the statement. It could be the time when the transaction got finalized on the ledger of the DLT. So that's still sort of discussed in our working group. It could be both. Next slide, please. Okay, so I'm going to go through the flows in more detail, and this is the red tag there. Next slide, please. You've seen this diagram many times today. So 3 stages: transfer initiation, lock assertion, receipt, and commitment. Next slide, please. So this is the transfer initiation, which is stage 1. And this is where a lot of things need to happen between the originator. So we're using the word originator and beneficiary, borrowing from FATF. FATF is the global organization that manages definitions of assets and so on, particularly in the context of anti-money laundering and counterterrorism financing. And so we're using that terminology so that when they see it, they know it's the users that are on the applications that are trying to do this. So in this stage 0, although it kind of doesn't exist, stage 0, we assume that the applications have talked to each other, and now Alice, the originator, has somehow invoked gateway G1 to do something to the asset on behalf of Alice. And this is where it moves to stage 1. And in stage 1, the idea here is that the gateways need to validate information about not only Alice and Bob per FATF regulations, but also information about the owners of the gateways, right? So in the FATF document recommendation 16, which is, you could just Google that, it's a public long document, and some of the text is copied into our terminology. The gateway operator is sometimes called a VASP, Virtual Asset Service Provider, because it has these legal obligations under some regulated jurisdiction to do certain things. So all of that, by the way, is out of scope for us. It's meant to illustrate the background for somebody who's in this space. They'll recognize some of the terminology, and also to indicate that stage 0 and stage 1, it's a lot of work that's out of scope for us. And before all of this, can fly. These verifications in stage 1 need to happen between G1 and G2. Okay, so next slide. So this is really where our stuff comes in, right? And this is, so begins with the origin gateway saying to gateway 2, let's commence. So now transfer commence, step 2.1. G2 needs to specifically acknowledge this message, to say in a sense it's a keep alive. It's also a ping back to say, yes, I know this is the session ID that I'm answering. Now, step 2.3a and 2.3b is where the gateway performs the lock, the disablement of the asset in network 1. Now, you might ask, well, it's already doing this in 2.3.a. Why is it doing a status check? So in some cases, it could be that network 1 is a ledger that takes time for the local transaction, disablement transaction, to be finalized, right? So this is, for those who know blockchain languages, settlement finalization. And so we thought, well, maybe before G1 proceeds, it needs to do 2.3b to check. Yes, is it true? Is it finalized? Yes. Now I have confidence that this thing is going to be locked for either permanently or duration of time, out of scope for us. But now G1 is able to produce the signed assertion in step 2.5 with confidence. And I need to apologize because step 2.5 and 2.4 are in the wrong order. So in fact, 2.5 should be numbered 2.4. You notice that. I didn't want to change the diagram a week before the IETF because this is going to confuse folks. So basically, G1 says, here, I now assert that the asset has been locked or disabled, or it's under my control. So the language sometimes used is that G1 now is in control of the asset that Alice has requested transfer. Then G2 performs a log evidence. It needs to log some of this stuff for its own recovery needs, for its own legal protection. And now G2 says, okay, I'm going to send you a receipt specifically. This is an explicit receipt that says, yes, this is the lock that I'm talking about, and here's a receipt for it. And it also implies that G1 is ready to commence to the next stage. Next slide, please. Thanks. So this is where your undergraduate database 1 class or database 2 class, depending, comes in, and you'll be familiar. This is if you guys know Jim Gray, it's a famous paper from 1978. Jim Gray was, I think, ended up being the CTO for IBM databases, but he came up with a lot of these, language, particularly things related to the acid properties. So G1 says, okay, get ready to commit. So this is the commit prepare message. So by the way, we're stealing this. If you look at the database books, this is precisely the language: commit prepare, act prepare, and specifically stealing from it, because I hope you guys do open your database textbook and find this, because that's the precise same words. Act prepare. So it's basically Gateway saying, yes, I've received your commit prepare message. I am going to do my job now. And so it does its job, which is in 3.3a. So 3.3a and 3.3b, what's unique about this is that Gateway 2 is already pre-minting, it's already created the asset, except it's assigned to self. It's not assigned to Bob yet. The reason is it needs to be able to then move ownership of the asset locally to Bob very quickly later on in the next slide. And as before, we've inserted 3.3b as just a consistency check. Yes, it's been local transaction has finalized. Now 3.4 is the signal back from G2 to G1 saying, okay, I'm ready for you to pull the trigger, right? So remember, before the asset has been locked, asset has been recreated, it's under the control of G1 and G2, and this is why it's important that they have legal owners, because there's liabilities there. And then once everybody's ready, both ready, then G2 says, pull the trigger, which is the next slide. Okay, so G1 now destroys, extinguishes that. So we're using the word burn generally, extinguishment and so on, because we have no way to know in advance what technology is being used in Network 1 to burn the asset. And as before, does a check after it does the burning. And so now in 3.6, this is the famous commit final. So in the commit final, G1 is saying, okay, I assert that I have just destroyed the asset in Network 1.
Thomas, can I interrupt you for one second?
Please.
So I want to be clear about your use of the terminology, because you just confused me. Is the diagram going to change extinguishes to burn later, if that's what we decide is, or
Yes.
are they two different
Correct.
things?
No. Burn. I didn't want to update this diagram a week before the IETF. Absolutely right. So anytime you see, I'm going to use the word burn. Okay, from now, my bad. Sorry,
no, my bad. I just didn't understand.
No. So 3.5a is a burn. I have burned the asset. Okay, and now it's saying, it's making the statement in 3.6. It's a signed, digitally signed, legally binding assertion. So if G1 lies about this, the operator is liable for it, right? Beyond that, we have no way to know this, because the network could be private. It could be a database, private database. We can't peer into it. We can't see into it. And so now G2, who receives this message saying, well, I already created the asset earlier. Now I can just do a quick assignment to Bob. So that's also very fast, right? So once G2 does that, it performs acknowledge the final act back to G1 saying, okay, I now sign an assertion saying that I have assigned the asset to Bob, the beneficiary in Network 2, right? And then optionally, 3.9 is optional if G1 wants to say, well, you know what, yes, this happened at this particular time. I'm going to write it to my ledger or my local database. Yes, we think 3.9 is very useful. And then the whole thing is closed in 3.10. So that's kind of the flow. And this is the core of the protocol that the working group is seeking to standardize. And as you just heard, there's a lot of unknowns, because this is we're talking about network to network, and we have sort of minimal capability to know what's behind each network. On next slide, I think this might be the last one. I think we did that slide before. Next one, okay. And I'm happy to go back to any of the slides. And
Thank you. So if we can open the floor to any questions or comments. No? Okay.
So I have one. This diagram and this flow have changed a lot over time. How stable do you think is it? you're talking about it all the time in the meetings, you know, but I think it's becoming more stable.
Yes.
How are we doing?
I think we're pretty stable. I think other than my typo there in section line 3.4, 3.5, I think we have agreement in the group that this is the flow, and the task of the core spec is to detail all the payloads, as I saw before in slide 2, right? Session ID should be there, and so on and so on. But quick answer is yes. This is now version 16, and at the end of the IETF, I hope to do that typo correction and remove the word extinguish and use the word burn consistently, and update that to become version 17. And if you look at the online version, there are these blue comment lines and the circles, ellipses on the sides. That's meant to represent the state of the asset in each network.
Thank you. If there are no questions or comments on that, I think it might be worthwhile doing a show of hands poll, which I'll set up now. We'll leave that up there for a minute or two if people can cast their vote. Okay, so that's probably it. We do have one do not raise hand. Can I invite whoever did that to talk about it, and what, optionally, if they don't have to, it's just to understand where that any concerns might be. Okay.
There's 2 raised hands.
Yes.
Raised hands. Yeah.
David, if I can invite you first.
Okay. Maybe I'm not certain what the word adoption means, but I still have, I still, in the protocol document, I think there's some major omissions. So, I mean, so I'm not,
Well,
as I said,
you?
Okay, I mean, mostly the thing that I notice mostly about this protocol document is we don't seem to be dealing with errors or failures. I mean, in fact, the word error and failure barely appear in the document. So,
yeah, I think what we're asking, the word adoption, working group adoption, means that is this the starting document that the group is going to, begin work on? And yes, there are no error sections yet. This is where we're kind of, with this, we're probably halfway through, probably even less. But yeah, yes, David, there's more we need to do, but this document needs to be the formal document that the group works on, is my understanding of working group adoption.
Just to recap IETF process, work comes to a working group, as an individual submission, and then there's a call for adoption saying, this is the right starting place. There's nothing, it may be still missing stuff, but nobody disagrees that this is the wrong direction to start with. And when it becomes a working group document, it's no longer the authors. It's actually the working groups, and the author still gets to make changes, but the working group actually has the absolute ability to say, Thomas, you're wrong here. We don't care how many times you're right. You must change this document in this paragraph in this way to match the consensus of the working group, regardless of what the actual editor of the document wants. So a call for adoption in the beginning is really, is this the right starting document for the working group to take on? It is not the conclusion where we actually want to publish it as a standards document. That comes after everybody agrees that it's final done, and there will be a working group last call, which is what we will start saying the working group's done, and then it'll go through the entire IETF process even after that. But does that clarify things, David?
yes.
Did you want to bring up some, we have time, so if you wanted to bring up some of the things that you have concerns about, I think, this is why we have these meetings, and feel free to voice.
Well, as I said, I think we just have to look, this is an application layer protocol, and I think we have to look at each step and see what the consequences, what has to be done at each point where there's a failure or an error or whatever.
Thomas is nodding his head
Yes,
vigorously.
absolutely. Any one of those lines could just like you lose the message, or the gateway, one of the gateways or both could disappear. They crash. Like what happens? That's why we need discussion in the working group.
All right, thank you. Warren, you dropped away. You were there.
I think the chair has asked. I think the chair said that there was somebody in the room who didn't, raise their hand or not raise their hand, and I'm just going to explain why. It's because I was reading mail and wasn't paying any attention. I have no views on adoption.
So wait. So did you click "Do not raise hand"? There was one person that clicked "Do not raise hand." That's the person I was wondering about.
Okay, never mind. I thought the question was who didn't bother participating at all.
Who
As
was
you can tell,
asleep?
I'm paying huge amounts of attention to what's going on, and not sidetracked into other stuff at all.
Understood. Thanks, Warren.
Anything else?
So I think we can go on to any other business slides. Dennis is not here, but Rama is. He wanted to talk about large state views.
Okay. Good.
We'll thank and excuse.
Okay, thank you. So that closes that section. We'll skip over documents ready for adoption as we've covered that off as we've gone through each document, which brings us now to any other business. We did have a question from Dennis. I can't see him in the room. So Rama, did you want to introduce the topic that you had in terms of legislate state views?
Sure, I can just do it really briefly. There are, I can share my screen, right?
Yeah, you can request screen sharing. It should be the button that looks like a screen with a slash through it, weirdly.
Okay, I just did that.
And we have to approve it.
It says all the slots for the requested media are already taken.
I clicked it. Did you click it? We've both tried to
I'm
click
getting a
it.
huge bunch of pop-ups. Let me then just do something. I'll post a couple of links on the chat.
Well, try it. See if you can try it again. Go ahead and try a screen request again. And
Okay, just it. I'm still getting the same bunch of pop-ups.
all right, why don't you drop the
Mention-
slides and if you have a link to them or something, we can.
It's not a slide. I'm just dropping links to 2 drafts that I'd uploaded last year. Here's one. And
That's it. Wait, which document? Oh, drafts.
Yeah.
Okay.
yeah, so these are 2 documents that describe one of the more that is alluded to in the architecture document. If you see the architecture document, there are sort of categorize the applications of or the need or the need for interoperability among different, especially blockchain or DLT based systems,
Hey, Rama?
which fall in. Yeah.
Sorry, try requesting a screen share again. I think I figured out the problem.
Okay. 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 You can.
There we go. There's the infinite recursion we all know and love.
All right. Okay. So now I can present some slides. What you see here is, I mean, imagine, think of, again, think back to basics of databases. A view into a database is a query one asks of a database, and you get some particular subset of the database in response based on which is extracted from the latest snapshot. So translate that into the blockchain world. What you have is you have 2 networks. Okay, these 2 assume these are partitioned by network boundary. There is somebody in one network who wants to know some subset of information in in a different network as is recorded in that network's ledger. So the view is the terminology we use to describe that. It's information derived from a ledger. It's in a blockchain system. It's kind of proof of the state of that particular blockchain. So it's not just information. Like in a conventional database, you would just extract the information based on the in response to the query that the client poses. But here we need both the state as well as the proof, because you have because this query is cutting across network boundaries, across ledger boundaries. So what you want, and this is a security concern, which is that one cannot trust the word of just one party that is sharing the particular ledger. Okay, remember this is this can be underneath this, or maybe over it, is a network of peers which are maintaining this ledger in sync, and they're using some kind of a consensus protocol to agree on what the latest state of the ledger should be. What this view requires, or what when we say in the DLT parlance we call it the view, is it's your conventional database view plus some sort of proof that indicates that whatever information is returned is a consensus view of the parties which are sharing that ledger. So that is the succinct way of talking about it. And this is especially significant in permission ledgers or private networks which are by default opaque to outside entities. And views can be going from this simple one piece of information, like if the ledger is built on key value pairs, you're just requesting the value of one particular key, or it can be a collection of keys, or it can be some sort of function that you're running over the entire state of the ledger. The associated with the view is what we can call a view address, whereby it's kind of like a URL, and hopefully, I mean, when we get make some advances, this can be, we can think of how to standardize this in the same way as the URL standardized. The requester asks for a particular view by formulating a view address, and I still have the old term ODAP, which was the earlier name for SATP, but you can think of this as SATP. So you can have, you can see here that different kinds of distributed ledger technologies. There's one called Hyperledger Fabric, and called Corda, which many of you may know. And we can create such view addresses, which mostly look the same, but there are, if you look inside, there are some differences based on the how the ledgers are themselves structured internally. So as long as an external party knows how to address a particular piece of information, it can formulate a view address. It sends, it makes a request of a different ledger and gets back a view. So that is the notion. And what is not explicitly specified here is this should happen through gateways. So you have one network, there's an SATP gateway, and there's an SATP gateway here, and the part again that we would like to standardize here is not whatever is going on at the back. We don't care about what contents are in the view, about how the data is structured, and so on. All we're concerned about is whether a particular SATP gateway can communicate a view address and get back a view in response and do some basic validation checks. In our system, this is called the system called Cacti under Hyperledger, under the Hyperledger Foundation, where we are trying to build solutions for general purpose interoperability across both permission and permissionless networks. And something like asset transfer is one of those features, which is what we are trying to standardize under SATP. But there's also just a general notion of sharing data across different ledgers, which allows two networks to interconnect and just communicate the state. In effect, we are taking two different state machines, and we can build a bigger virtual state machine across two different networks and two different workflows without forcing an integration of the two different networks. This is what, if you remember the use case involving the trade finance network and the trade logistics network, that's what that was trying to convey. So these are just data structures copied from the Cacti project. So there's also it looks very complex, but a long-winded protocol for communicating, for requesting a view address via gateways. Again, in Cacti parlance, we call it relay, but that's meant to conform to whatever however we standardize the SATP gateway. You're supposed to make a request from an application one network to another network, get a this network generates proof. It also runs access control checks to determine whether or not the request can be satisfied, sends back response, and then the network here validates that proof. It's not just up to the application to just submit that that information. So yeah, this is the part that is in the, if you look at the draft that I shared, let me see. Yeah. So there are two drafts. One of them talking about views and view addresses, and another talking about the request response protocol. And yeah, this is sort of the ASCII art version of the protocol. So yeah, thanks. That's all I wanted to convey. This is, again, to be clear, and as I'm sure Wes and Claire will remind you again, this is not in the current scope of the charter, but later on, once we've done standardizing the asset transfer protocol, I'd like to bring this up again for discussion. And but please feel free to look at the drafts and give me or give any of the authors comments. You can share that in the mailing list. Thanks.
All right, thank you, Rama. Anybody have questions about that, Rama's discussion and of future work items, as he said? So. All right, hearing none of that, is there any other business people want to talk about? That includes any applications of SAT protocol or anything else? Any questions for anybody? You want to talk about something else? Feel free. This is open mic session at this point.
So hi, Thomas again. So I know there's another person. Dennis is writing up probably a draft about how to derive session ID. It's out of scope right now, but it's good to have something written because we have to have a common understanding of at least one possible way. There is another draft by Shipping Chen, which is in the, I think it might have been expired, and that's on gateway identification. So if you remember my slides, there's a thing called in the payload, there was a network ID, and surprise, surprise, there is today no standard for identifying ledger network ID. There is no AS number. There is no, there is no body like Aaron where you can say, give me an AS number. It doesn't exist, right? So we're trying to, Shipping is trying to create a way to quickly identify gateways so that you can verify the owner and so on and so on. That's a future work item as well. There's a rudimentary draft that needs to be updated desperately, I think. But yeah, that's future work.
Excellent. Rama?
Thomas, you mentioned the draft that Rafael had been working on once for log management at the gateways, right? That's also future work, or do you think that kind of fits into what you're doing here?
Yes, I don't want to speak on behalf of Rafael, but yes, I think that's a possible future work item because we do get questions. I get questions all the time about what happens if the service goes down, the gateway goes down. So I think that's a future work item, I think.
All right, does anybody else have other items for the working group before we close it for the day? I hear none and I see none, so there is no evil, and which is a well-worthy national heritage site in Japan. I've seen it. I've been there to the Hear No Evil, See No Evil monkeys. They're fantastically carved, and they're not that far away. If you're going to be in the country for a little bit longer, I won't be, but they're worth visiting at Nikko. All right, thank you, everybody. Appreciate your attendance and cooperation, and we look forward to, remember, lots of interim meetings, so come join us for the interim meetings.
Thank you.
So that could be a time zone issue. So it is 10 o'clock.
So
That would be what he's doing.
should be, that's something that the user,
So it could be that the Washington DC.
this is where I'm going to.
We got an early slot in San Francisco, I think.
Hi there. I just wanted to say, I realize it can be really annoying when some charge shows up and tells you to rewrite your document, which I have done to you twice this week. So please, if I'm over, tell me to back
John,
off.
so I always appreciate your comments because you're, as I said in the beginning, right, I actually have no stake in this game.
Yeah.
I'm here to help new participants, do some new work in the IETF. So I turn over my expertise to everybody else. But I do know that people have thought about that. And I think nobody was prepared to answer today because
The 2020 or 22
Yes.
thing?
Yeah, it's
Yeah.
not an area of expertise, but I do know that it has been considered.
Yeah, well, I mean, I think there's a reasonable story to be told, like 2020 or 22 addresses these things, and we're still in the class, so we're going, but also 20 or 22, it's the ISO, so
it's also not open.
well, it's open to the extent that if you want to implement it, go right ahead, but then you have to find someone who will talk to you using it.
Well, that's true for this too. I mean, so the assumptions in this have always been that the gateways have some sort of agreement between them that they're willing to transfer.
Yeah. Well,
Okay, exactly.
yeah, also,
Back to the legal part.
yeah, there's something I would really like to enable is, you're